So this is the Spongebob problem that we were discussing in class, where Spongebob is speeding along at a constant velocity, his top speed of 34.7 meters per second. And he passes Mermaid Man and Barnacle Boy here in the invisible boatmobile. It's hard to draw something invisible, so I've put dotted lines there. They're sitting there at rest, and then at the instant that Spongebob passes them, they start accelerating. So their accelerating is 2.2 meters per second squared, and their maximum velocity is 52.8 meters per second. So at time equals 0, they're at the same place. SpongeBob's moving at a constant speed, so he gets a head start because he's already moving. And then at some later time, we know that Mermaid Man is going to catch up to him because eventually he'll get to his top speed, which is greater than SpongeBob's top speed. So they will definitely catch up. So over here at some later time, we know that their positions are going to be the same. That's what it means for them to catch up to him. So we want to know how long that takes and how far they've traveled in that amount of time. So that means that we need to find equations for SpongeBob's position and for Mermaid Man and Barnacle Boy's position. But the thing we have to worry about is there's a few possibilities. So we could have a situation where they never reach their top speed. They catch up to SpongeBob while they're still accelerating. There's the unlikely situation where they catch him at the exact instant that they reach top speed. Or the other option is that they reach top speed and still haven't caught up to SpongeBob, so SpongeBob is still in front of them, and then they continue at where they're both at a constant velocity for a while until they catch up. So what we're going to do is see first how long it takes them to reach their top speed, and then see how far they've traveled in that time and compare it to SpongeBob's distance and see if they catch him or see if they reach top speed before catching up to SpongeBob. So what I've written down here is the position equations for Mermaid Man here and SpongeBob, and I've written them the most general way possible. Should have a plus sign here, including all of the possible terms. Now, for both of them, since they start at the same position, we can just say that their initial position x0 is equal to 0. So that's a nice convenient choice. And Mermaid Man and Barnacle Boy start at an initial velocity of 0, so that term is going to be 0. And SpongeBob is not accelerating, so the acceleration term is going to be 0. So the position that Mermaid Man and Barnacle Boy, during the time that they're accelerating, their position is just given by this 1/2 AT squared term, and SpongeBob the whole time is given by his velocity times the time. Now, in order to figure out this distance, if we're saying what distance did they cover during the time that it takes them to accelerate, we need some more information. So we need to use the velocity equation. So that's their final velocity, so V max we called it, is going to be equal to their initial velocity plus acceleration times time. Now again, their initial velocity is 0. I've just written it there so that I remember that I've considered all the terms. So their maximum velocity is acceleration times time. Now what we want is the time, so I'm going to divide both sides by the acceleration, and I get that the time then is equal to V max divided by the acceleration. I have those quantities here, so their maximum velocity was 52.8 meters per second, and we divide that by the time, by the acceleration, which was 2.22 meters per second squared, and that gives us a time of, let me look at my notes, a time of 23.8 seconds. So to figure out how far they've gone, we can take that time and plug it into this expression with the same acceleration that we've been using, 2.22 meters per second squared, and we get that they have traveled a distance of 629 meters. So that's how far they've traveled during the time that it takes them to reach top speed. Have they caught up to Spongebob yet? We don't know. We need to check. So to check that, we take the same time. So where is Spongebob at this time? After 23.8 seconds, when Mermaid Man and Barnacle Boy have reached their top speed, where is Spongebob? So we use his velocity, 34.7 meters per second. Multiply that by the time, 23.8 seconds. And that gives us that Spongebob is at a position of what? Spongebob is still ahead. He's at 826 meters. So that means that they're going to continue on for a while. So now what we can do is we can do a new problem. So we'll take initial positions based at the end of the acceleration for both of these and do a constant velocity problem to figure out how much extra time it takes them to catch up. So after reaching top speed, a time that took 23.8 seconds, now everybody's at a constant velocity. Mermaid Man and Barnacle Boy are at 52.8 meters per second. Spongebob is still at his 34.7 meters per second. Acceleration is equal to 0 for both of them. Mermaid Man in this new phase starts at 629 meters and Spongebob starts at 826 meters. So now we can look for say an X final. Right, so our final position that I'm calling this is where they finally catch it. So for Mermaid Man and Barnacle Boy, we can say that X final is equal to the position where they start here, which we called XM, so that would be the 629 meters, plus their velocity, which we called, we actually called this V max. So V max times some new time. So if you want to distinguish between these, you could say this is time 1, right? That's the time for the first interval where they were speeding up, and this is the new time that we need to find out, time 2. And then the total time is going to be time 1 plus time 2. For Spongebob, we have X final is equal to this XS, 826 meters, plus velocity of Spongebob times time 2. And these final positions have to be the same. Right? That's what it means for Mermaid Man and Barnacle Boy to catch up to Spongebob. So if this final position and this final position is the same, that means that this right-hand side of the equation is equal to that right-hand side of the equation. So I can write xm plus Vmax times T2 is equal to xs plus Vs times T2. Now the only unknown in this equation is the time. So what I want to do is get all the terms that involve time on one side of the equation. I do that by adding or subtracting the terms. And all the terms that don't involve time on the other side, again by adding or subtracting. So I will, on this side, I will, let me change color. I will subtract x sub m. On this side, I will subtract x sub s. Or sorry, I will not. I will also subtract x sub m. So now I have Vmax T2 is equal to xs minus xm plus Vs T2. Showing all the algebraic steps so I don't lose anybody. So I ran out of room, so I just recopied that last step here. And so now I want to get this term onto the left-hand side, so I'm going to subtract Vs T2 from both sides. That gives me Vmax T2 minus Vs T2 is equal to XS minus XM. Now I can factor out T2 from this equation. I want to make sure this board's working. So factor out T2 on this side, so that's T2 times V max minus Vs is equal to XS minus XM. And then finally divide both sides by this quantity. So I'll get T2 is equal to XS minus XM divided by V max minus Vs. Oh, let me tilt that down. There you go. V max minus Vs on the bottom. So this gives me time 2, which if I plug all that in, I will get 10.9 seconds. That means that the total time is equal to T1 plus T2, which gives me a total time of 34.7 seconds. And then I need to find the distance covered in this second time. So I can take T2 and plug it in and multiply it by either of the top speeds. Right, or plug it into the distance equation for either one. So we have, for instance, for Mermaid Man, we have xm was equal to, or sorry, x final, we were calling it, was equal to xm, which was 629 meters, plus v max times t2. So that's going to give me 629 meters plus V max was 52.8 meters per second times times just T2, which is 10.9 seconds. Which ends up giving us around 1,200 meters. All right, and that's it. Mr. White Dog,